Next, we are solving the trig function, trig equation. Square root 2 times sine x plus 1 equals 0. First of all, isolate x by itself. Subtract 1 both sides and divide by square root 2 both sides. We have sine x equals negative 1 over square root 2. For sine function negative, the angle will be in quadrant 3 and quadrant 4. And angles that if you sine as negative 1 over square root 2 would be 5 pi over 4 and 7 pi over 4. Next equation, cosine of 2x equals, next equation, cosine of 2x minus cosine x equals negative 1. With the identity cosine 2x equals 2 cosine square x minus 1. We substitute the cosine 2x or replace the cosine of 2x by 2 cosine square x minus 1 and minus cosine x equals negative 1. Or we have 2 cosine square x minus cosine x equals 0. Factor cosine x. We have cosine x multiplied by 2 cosine x minus 1 equals 0. Cosine x equals 0 gives us x equals pi over 2 or 3 pi over 2 for the first revolution. The second factor gives us cosine x equals 1 over 2 or x equals pi over 3. Cosine x equals 1/2, which is a positive number, positive sign. The cosine is positive in quadrant 1 and quadrant 4. Pi over 3 in quadrant 1 and 5 pi over 3 is in quadrant 4. Transformation of sines and cosine graphs. Y equals A times sine of B multiplied by quantity beta minus C plus D. Or Y equals A times cosine of B multiplied by the quantity beta minus C plus D, where the numbers that represent by A, B, C, and D will tell us the behavior of the graph. Absolute value of A represents the amplitude of the graph. Two pi over B will give you the period of that graph. C tells you about the horizontal shift, or it's called a phase shift. D tells you the vertical shift. Example 1. Identify the amplitude, period, horizontal shift, and the vertical shift of the following function. The function p of t equals 2.5 times sine of 2t minus pi over 6 plus 3. We're going to rewrite it in a form that we can tell what are A, B, C, and D. So 2.5 times sine of 2 multiplied by t minus pi over 12 plus 3. That tells us A is 2.5 and B is 2. C is pi over 12 and D is 3. The amplitude is the absolute value of A, or 2.5. The period is 2 pi divided by b. In this case, the b is 2. Therefore, the period is pi. The phase shift or the horizontal shift is the value c, or the value pi over 12. The vertical shift is d, or 3. If you look at the graph, you would get the one cycle that starts at pi over 12 with the period pi. So this point will be pi plus pi over 12, or 13 pi over 12. And the graph has the vertical shift at 3. This is a sine graph. It will look similar to this. Next example, find a trig function that satisfies each set of properties. Answers are not unique, so it depends on you look at it as the common sine or cosine function. Let's take a look at information. The period of 6 hours. The minimum value up to at t equals 0. The maximum up to at t equals 3. In this case, the minimum value at t equals 0, the maximum value 2 at t equals 3. To find the amplitude, by definition, amplitude is the max minus min in the absolute value divided by 2. So absolute value of 2 minus negative 2 divided by 2 gives us the amplitude is 2. And the period equals 6, which is equivalent to 2 pi over b. Therefore, the b is pi over 3. Actually, the amplitude is absolute value of n. So it could be negative 2 or positive 2. If you plot the graph, you get better idea about the graph, the sine or cosine form. At t equals 0, the minimum of negative 2. At t equals 3, the maximum of 2. So the graph rising from negative 2 to positive 2 with the period 6. So that means from 0 to 3, that's a half of the period. And it looks like this graph is the reflected cosine graph. If it's reflected cosine graph, so A gonna be negative, or we have A equals negative 2. So before my equation, y equals A times cosine of quantity b x minus c plus d. In this case, no vertical shift, no horizontal shift, so c and d are 0. Therefore, we have y equals negative 2 cosine of pi over 3 times x. Next example, a light block hangs at rest from the end of a spring when it is pulled down 10 centimeters and released. Assume the block oscillates with an amplitude of 10 centimeters on either side of its rest position and with a period of 1.5 seconds. Find the function d of t that gives the displacement of the block t seconds after it is released, where d is greater than 0, represent downward displacement. From this information, the problem said the amplitude of 10 centimeters. So absolute value of A is 10. The spring is pulled down 10 centimeters. As pulling down is positive D value. Therefore, the A is 10. The period is 1.5. Which is pi over B. That gives us B equals pi divided by 1.5 or 2 pi, no, pi period is 2 pi over B, sorry. So B is 2 pi divided by 1.5 or the B is 4 pi over 3. So the equation for this displacement would be 10 times cosine of 4 pi over 3 x from the graph. At the pull down position 10 centimeters and the period of 1.5. 5 seconds.